Okay, let's go through the parametric differentiation from 2015 question. So of course the first part quite simple lah. First part show that the dy dx is equal to be as such. So this one you simply just use the, for example, right, dy dt is equal to dy dx multiplied by dx dt. So you just make your dy dx the subject. So should be able to get 2 cotangent theta minus tangent theta. Okay, so for part 2, I just want to mention about part 2. So part 2, we are asked to show that the stationary point is equal to tangent theta. Tangent theta equal to square root k, where k is an integer to be determined. Okay, first, we just need to let this dy dx to be equal to 0. Then of course, maybe I write here. So I let it be equal to 0. Then I need to change the cotangent, right? Because this is initially your cotangent theta. 2, I think it's 2, yeah, 2 cotangent theta. You change to tangent theta first, and then you times tangent theta throughout. So of course you will get tangent theta to be plus, square root 2. Because tangent square theta is 2 so tangent theta will be just square root 2. Okay, but you might be wondering how come it's not plus minus? Because we are only interested in the theta in the first quadrant, meaning from 0 to 90 degree. So there's no need for negative square root 2. Okay, with this, right, we know that k is equal to positive 2. Okay, now the real question comes already. How do we actually do the next part? Find in non-trivial form, right, the exact coordinate of the stationary point. Meaning, we want, what is the x, comma, what is the y bracket? So, first thing first, we must always draw the right angle triangle. For example, okay, tangent theta is equal to square root 2 over 1. So I can just write tangent theta equal to square root 2 over 1. Then after this, right, we draw the right angle triangle. So you can see, this is your adjacent. So you can see, this one is your square root 2 divided by 1. Of course, I use Pythagoras theorem. I can actually determine what is your hypotenuse. So a square plus b square. So it's 3, right? Then you square root 3. So that will be a hypotenuse. Okay, with this, now I want to determine the sine theta and cosine theta. You'll understand why later. Okay, sine theta is equal to square root 2 over square root 3. Because it's tuaka so, it's the so, right? Oppo divided by hypo. Okay, what about cosine theta? Cosine theta is 1 over square root 3. Okay, why I want to find these two things? Because if you go back to the parametric equation of the question, so you can see x is equal to sine cube theta, y is equal to 3 sine square theta cosine theta. So now the key thing about this question for part 2 is not to find theta, is to find what is the x and what is the y. Okay, let's write down sine cube theta, right? So for example, our x is equal to sine cube theta. So we already know, okay, my sine theta is given to be as such. So means you just need to cube the whole thing. So square root 2, square root 3, you cube. But you don't press into calculator, because you press into calculator, they'll give you a very not very nice number. They want exact form. Meaning you should be able to get manually you should get this. Then of course this one is 3 square root 3. So that will be the x value, but try to rationalize as much as possible meaning, for example, right, this one you times square root 3, then top part you also times square root 3. So this will give you 2 square root 6 over 3 bracket 3. So this will be 2 square root 6 over 3 times 3, 9, right? So that is the x value already. Okay, now it's time to determine the y value. Okay, y is equal to 3. Okay, I go back to the question first. Sine square cosine theta, sine square cosine theta. 3 sine square theta cosine theta. Okay, so 3, right? Okay, sine square we know is square root 2 square root 3. Okay, cosine theta is 1 over square root 3. So this will give you 3. Okay, this square root 2. 2/3. So at the end of the day, of course, you can see must also rationalize this one. So 3, 3, 2 over square root 3. So this one is the y coordinate. So square root 3, square root 3. So this will give you 2 square root 3 divided by 3. Yeah, so apparently I got the x coordinate, I also got the y coordinate in exact value, meaning now my answer for that part will be 2 square root 6 over 9, 2 square root 3 over 3. So that is how we actually solve the part 2. So yeah, hopefully no more question. I mean, hopefully for the part 2 there's no more part already. Okay, yeah, so the rest I'll leave it to you.